So here I want to do a MICE problem, which is pretty much the same thing as a rice problem, but instead of using a recipe, we're going to do M, which is molarity, which is practically the same thing. And I'll kind of go over the difference really quickly. So we have the following reaction happening. We have NO gas reacting with H2 gas, and we get N2 gas and then H2O gas. And here's the recipe: 2 to 2 to 1 to 2. Now the difference is, instead of an inventory which is in moles, we're going to do inventory in molarity. So what that means is going to be moles over liters. So in the first one, we're just going to grab, I'll do the work for the first one, 0.150 divided by 1.5. So that's going to give us, I should be able to do this in my head, 0.1, and it gives us the moles of H2, 0.075. We're also going to divide it by 1.5. That gives us 0.05, and then we have 0.1 moles of H2O, so it's going to be the same one here, so 0.1 molarity. So the difference here is this is actually an equilibrium. So technically, I should do a double arrow. So I apologize I didn't set it up correctly. So that means there's no limiting reaction. We don't have to worry about it. But we do want to find Kc eventually. One of the puzzles is this. So somehow we went from 0.1 to 0.06. So that means some of this reactant changed. So what we could do is just subtract it. So 0.1 subtracted by 0.066 is 0.034. So that means this much reacted, and let me just double check just to make sure I did my math right, to this. Now, this is, remember, the ratio 2 to 2 to 2 to 1. So if this is how much it lost, anything with the same coefficient, we do the same thing, 0.034 plus 0.034, and this one is the only difference is if this is a two-parter, the ratio is 1 over 2, so this will be divided by 2. So 0.034 divided by 2, make sure I get that right. So this one's going to be plus 0.017. And that's pretty much it. It's going to start off at 0. This one's going to subtract, so 0.05 subtracted by 0.034. 0.016, 0.017, and then 0.1, I can do that in my head, 0.134. So this is where the concentration is for each equilibrium, so all we have to do is just plug that in. Remember, is right side over left side, so 0.017 by the coefficient, in this case 0, or 1, sorry. 0.134, and this one by the coefficient of 2. 0.066, and that's coefficient is 2. And then 0.016, and that coefficient is also 2. So then you just solve for that. Just plug that into your calculator. 0.017 times 0.134 divided by 0.066 divided by 0.066 divided by 0.016 divided by 0.016. Now I'm just doing it out of scientific, so I don't want to be too uncareful, just in case. I'll do it the long way. So we get this ratio. Remember, there's no units here. And that's how you solve it. So I personally think MICE is much easier than rice because you don't have to do conversions from grams to moles. This one, all you have to do is get the moles divided by the volume, so that'll give you molarity. Figure out what the change is, but the change is going to be the same ratio as the M. So remember, these two are going to have the same ratio. Meaning if it's 2 something, this is 2x, 2x, 1x, 2x. So you can just make them equal each other that way. Then you figure out the change, what's left, and this is the equilibrium that we're going to get here. Plug it into the equation, you have this. In a problem like this, it could work backwards. I could give you this, and you have to figure out one of these. So that's possible as well. That'll be a harder problem, but that is a possibility. All right, so that is kind of really quickly mice. I personally think is much easier than rice, but all you have to do, again, is to change this. And for this one, remember, only gases and aqueous solutions, no liquids and solids.